Hello. Today we're going to talk about graphing systems of equations. So this means that we have a couple of equations that we want to work together, and we want to be able to find the solution that works in both of them. So that's what's called a system of equations. So let's go over a few examples for you today. The first one is identify the type of system. So there are three different types that we'll talk about. So let's take a look at the example first of all. So here's our system of equations. The three types that could possibly be our answer are independent, inconsistent, and equivalent. All right, so what does this mean for all of these? So first and foremost, what we really want to look at is just get this system to where we can look at the slope of them. So that would mean that if we put them into y equals mx plus b format, that would probably be our best bet in order to look at the slopes and be able to identify these pretty quickly. The first one is in that format already, so we don't need to do anything with that one. But the second one we do. So we need to take the 2x plus 2y equals 8 and get it to solve for y. So we're going to subtract 2x from both sides. We get 2y equals negative 2x plus 8. And then we need to divide both sides by 2. And so then we get y equals negative 2 divided by 2 is negative 1, so negative x. 8 divided by 2 is 4. So we have our two equations here. Let's take a look at them. We have this one and this one now that we have them solved for y. And what do we notice about them? First and foremost, they have the same slope. Okay, so that tells us something. But in this particular instance, they also have the same y-intercept. So notice they're the same equation. So even though it looked very different when it was written as 2x plus 2y equals 8, what we realize is they're the same equation. So in this case, if we're identifying the type of system, we would say this one would be equivalent. Now, what is the difference between these? So independent means like that. I'm independent. I don't need help. So they are going to be very different from each other. So different slopes, and that's the main thing you're looking for. They have different slopes. And so that way that they would have a solution. They would have one solution to their system. Inconsistent would mean that they have the same slope. So they have the same slope, but different y-intercepts. So in this case, they have the same slope, but they have the same y-intercepts. If we had the same slope and different y-intercepts, it would be inconsistent because the two lines would never cross each other. There would be no solution. They're actually parallel. Excuse me. Equivalent means we can see that the equations are identical. So same slope, same y-intercept. In this case, if I were to graph them, they would be directly on top of each other. So that means because they are the same line, that there are infinitely many solutions, meaning every x and every y is a solution. All right, let's take a look at another example. Solve the system graphically. And what is the solution? So our system is y equals 2x minus 3 and y equal, nope, sorry. Let's go back. X plus y equals 3. So what your goal is here is to graph them on the same graph. These have to be on graph paper and a ruler used because you're trying to see where they cross, and so it has to be pretty precise. I would also recommend if you don't do them on graphing paper, that you can also do them in a free online software called Desmos.com. And in this case, you can graph them in there and keep it pretty easy to see. These have to be pretty solid, and you're not going to see that with this particular video, but I'm going to try my best to do that for you. So in graphing these, remember you're just graphing lines here, so you can use any particular method or shortcut possible. We can use the y-intercept, slope-intercept to graph them. In this case, the bottom one would have to be solved for y, so we'd have to subtract x from both sides and get y equals negative x plus 3 in order to graph that. That's totally fine. But let's go ahead and graph them. So the top one, 2x minus 3, means we start at negative 3 on there. And then the slope is 2 over 1, so we're going to go up 2 over 1. And in that case, then we're going to play connect the dots. And again, this is why I said they need to be very straight. Straighter than, so I can't really demonstrate that in this program. All right, the next one is negative x plus 3, so we're going to start at 3, and then the slope is negative x, so it's a negative 1 over 1. So we're going to go down 1 over 1, which would be about here, and then play connect the dots. And what you will see is where they cross. As you can see here, it kind of looks like they cross at the point 2, 1 right here. In that case, if it is 2, 1, you can always double check that by plugging them into both equations to see if it works. But that happens to be where it is. So notice if you're a little off, you're not really sure where they cross. But the solution to this would be the point 2, 1. All right, one more example for you. It wants us to solve the system graphically. 2x plus y equals 3, and 3y equals x minus 12. So again, we want to graph these. You can solve them so that they are y equals. So if we take the first one, 2x plus y equals 3, we need to subtract the 2x from both sides. And we get y equals negative 2x plus 3. The bottom one, we have 3y equals x minus 12. We need to divide everything by 3. So in this case, we get y equals, there's a 1 there, so it's 1/3 x. Negative 12 divided by 3 is a negative 4. Can't really see that. So y equals 1/3 x minus 4. Okay, so now we want to graph these on the same graph. Okay, so the first one here, we're going to start at 3. That's our y-intercept. And then go down 2 and over 1. And so there is our line for the first one. And then the second one, we start at -4. And then our slope is 1/3. So we go up 1 over 3. And so here we draw that one and cross it. All right, so now we see that they cross here, and it's kind of like, where do they cross? Kind of looks like maybe it's 4, -3. And again, this is why it's so important to use graph paper and a straight edge, or to use a program like Desmos, because if I plug these back in, 2 times 4 is 8. 8 minus 3 is 5. 5 does not equal 3, so this does not work. So accuracy is key because I have no idea, somewhere I messed up in my graph. In this particular problem, what actually ends up happening is they cross at 3, -3. And so if you were accurate in your drawing, then you would see that that's where they cross. And so it's also good to check and plug them back in to make sure that they work. So the solution to this one is 3, -3. That's it for this lesson. Again, as you work through your lesson, if you have any questions, ask your teacher. Have a great day.